Hey, this is Mr. Warden. This is Algebra Do Now 24.3 video key. And so the next time you went on a hat shopping spree, you went to the bargain hat store. You bought 2 pointy hats and 3 propeller beanies, spending a total of $43. Your friend bought 3 pointy hats and 2 propeller beanies and spent $47. What are the unknowns here? Well, you know how many hats of each type you're getting, but what you don't know is how much pointy hats cost, and you don't know how much propeller beanies cost. Okay, those are the things you don't know. I'm going to go in order and say X equals how much pointy hats cost and Y equals how much propeller beanies cost. And there is a pointy hat from the Middle Ages. Okay. So you bought two, and your friend bought, so you bought 2 pointy hats and 3 propeller beanies. So we can come up with an equation where it's 2 pointy hats times X dollars per pointy hat plus 3 propeller beanies times Y dollars per propeller beanie, and that's going to add up to 43. And you can also create another equation for your friend who bought 3 pointy hats and 2 propeller beanies and spent $47. So those are your 2 equations. They are standard form equations, and there is actual footage of a propeller beanie allowing someone to fly. That's pretty awesome, isn't it? And now I'm going to copy pasta these 2 equations really quickly. We're going to go into Desmos, and we'll plot those. I'm going to first make a note so I can just put that text in there. And we're going to plot 2x plus 3y equals 43. And we're also going to plot 3x plus 2y equals 47. And where are the graphs? Well, zoom out and you'll see them. There they are. And let's see, the green one is your friend's purchases, and the blue one is your purchases. And they intersect at the point 11.7. Okay? And we're going to label that point. We're going to say that is $11 per pointy hat and $7 per propeller beanie. And that is what that point means. That's what it's telling us. So let me copy paste that into our do now. So, okay, we get that. And that is the solution for our system of equations, because that's the point, that's the XY values that make both equations true. All right, now, let me take a look at this a different way. So if we tripled every part of this equation, this would be 2x would become 6x, 3y would become 9y, and 43 would be 3 times 43, which is 129. So you get this equation. 6x plus 9y equals 129. Now, if we doubled all parts of 3x plus 2y equals 47, that's your friend's purchases, we would get the 3x becomes a 6x, the 2y becomes a 4y, we're just doubling them, and 47 becomes 94. And then we stack those 2 equations on top of each other, and I'm just going to subtract. All right, so let's look at what happens when we subtract. 6x minus 6x is just 0x. So we will be ignoring that. And then 9y minus 4y is going to be 5y. And that's going to equal 129 minus 94. So let's deal with 9 minus 4 is 5. And then 2 minus 9, I'm going to have to borrow from, we'll just call that 12 minus 9. So that's 35. And now we can ignore the 0x, so we're left with 5y equals 35. And we can actually finish solving that by dividing both sides by 5. And then we'll end up with y equals 35 divided by 5, which is 7. And that is $7 per propeller beanie. A bargain at any price since it allows you to fly. Now, let's try it the other way. All right, so what we just did was we eliminated the x variable. And this is a method known as the elimination method. So we have eliminated it. It's fun to say eliminate. And now we're going to do the same thing with the other. So instead of tripling the first equation, we double it. We double 2x, we double 3y, we double 43. And 2x becomes 4x. And 3y becomes 6y. And 43 becomes 86. Now we take the other equation, and this time we're going to triple it. And the 3x becomes a 9x, the 2y becomes a 6y, and the 47, 3 times 47 is going to be 21 plus 120, which is 141. So we're going to subtract the two equations from each other, and let's see what happens. So this time I put the one that equals 86 on the bottom. It actually doesn't matter which way you do the subtraction. It'll work either way. But I like it this way because I won't have to deal with negative numbers. So let's get subtracting. 9x minus 4x is 5x. And 6y minus 6y is 0y. And then we're left with 141 minus 86. Okay. Let's start doing that subtraction. So 1 minus 6, I'm going to have to borrow from the 4. So it's going to be 11 minus 6, so that's a 5. Now I borrowed from the 4, so that's now a 3. So 3 minus 8, I'll have to borrow from the 1. We may as well call it 13 minus 8. And 13 minus 8 is 5. So we end up with 55. Now, that's a 0y. Who cares about that? That can go poof. And now we've got a one-step equation. We will divide both sides by 5 to isolate the x and interrogate it and find out its secrets. So 5x divided by 5 is just x, and 55 divided by 5 is just $11 per pointy hat. And those are the two numbers we got when we graphed. $7 for a beanie and $11 for a pointy hat. And in fact, that was what we got. We got $11 per pointy hat and $7 per propeller beanie. And there you have it. We've just used the elimination method to eliminate one of the variables. I had to scale the equations up a little bit so that I had matching coefficients for y or for x. And once I had matching coefficients, I could just subtract and make one of the variables go away. That's why it's called the elimination method. If I had opposite coefficients, by the way, I could add, but I didn't. I had same, so I subtracted. Opposites cancel out. Sames cancel out when you subtract, so opposites cancel out when you add. Anyway, there you go. I hope that was helpful and gives you a little bit of a preview of levels 4A and 4B of systems.